Hi everyone, myself Srinivas Raju. I am CEO to company Unistring Tech Solutions. This short video I am making to bring out to go inside the deeper technologies, the R&D aspects that we do. Unistring Tech Solutions is an R&D company, and throughout this video I am trying to highlight whatever the core electronics engineering students and people with BTech, MTech background, what they study, how they are relevant to the practical industry when you are building a system which are related to communication, radar equipment that we build. Okay, please come with me. I'll take you to different areas in which we work and what are all products that we build, how those solutions are related to basics of your engineering that you study maybe in your BTech or maybe in MTech courses, those things. I'll first start with simple circuits. So all of you know that electronics, when you start maybe in your undergrad, BTech first year or second year, you start with electronic devices. So you study transistors, resistors, capacitors, then you understand how to make a switch, how to make a amplifier, how to do that. So the first section that I'm taking you to show here is the simple what you call as a level translators, switching circuits. Lot of the translation is required, the 1.8 volts logic family to 5 volts logic family and all that, and power supply systems. So you study about the AC-DC converter, DC-DC converter and all that. So here what I am showing you is that I am showing certain equipments which are where they are doing the endurance test of the power supply system. So these are DC-DC power supply system. So when I take you to the next part of the video, when I show you that in a electronic hardware, a military electronic hardware, these systems play a vital role in distributing the power supply, taking from AC to DC and carrying out further. So after this power supplies, I am showing you here some of the circuit related to the level translators. So where the control circuitry, when you are distributing from FPGAs to microcontrollers to i7, i3 computers and all, you require the level translation to be done. So here the testing is going on about some of the level translator circuits. So we at Unistring use these kind of what is called power supply systems and these control circuitries that are built with the legacy. Sometimes we use a legacy MOSFET and BJT. Most of the times we use the ASICs which are already populated inside with the necessary 8-bit level translator, 16-bit level translator, like that. Next, let me show you the very critical part in the military design. So in the military design, the most crucial thing is related to radio frequency circuits, what are called RF circuits. All of you studied that whatever works at maybe IF frequency like 20 megahertz, 70 megahertz and all, things completely change when you talk about designing at maybe S band, maybe C band, X band, like 6 gigahertz, 10 gigahertz and all. So we have a division in company with more than 30 employees who work on this circuit design and the RF circuit design. So here you can have a look. These are the amplifiers which are capable of going up to 6 gigahertz, covering up to 100 megahertz to 6 gigahertz. So these are different amplifiers. Okay, these are called low noise amplifiers that people who studied this RF and communications, they know the importance of noise figure and communicate. So we build these kind of things right from the scratch, in the sense we buy material, the PCB material like this RT Duroid, Rogers kind of high frequency PCB material. Then we design the PCB layout, we make the PCB layout. Then with the help of industry available in India, in Hyderabad and Bangalore, so we print that PCB, then we solder here. So let me take you to the next, the place where we have the soldering facility. Here you can see the different soldering stations that we have. So these are the setups that we solder, even the RF PCBs we solder. Then these are some quality inspection related, some equipment you need for testing the quality of the PCB. In military projects, there are a lot of certifications that are needed to check the quality of the system at different levels. So at the PCB levels, when they are doing soldering, to check the quality of the PCB and the quality of the finishing, that they will be using these machines, these places. So once that RF circuitry is actually, once it is done, in terms of circuit, once it is done, the RF PCB is made. Whatever I have shown you, that this is a kind of, because in RF it is very important to have what is called EMI/EMC, electromagnetic interference and all. Otherwise, each RF circuit can actually cause interference to the other RF circuits. So most of the RF circuits, they come in a small size of metal housing. So we have a mechanical division. The mechanical division actually designs this kind of the required housings, and we send it to the local vendors who use the CNC machines. So they do all the etching and whatever the design as per this, and they'll give. So at the soldering stations, the RF will be kept inside this, and here using the SMA connectors it will be soldered, then it will be tested. So then further, let me take you a full populated product. How does it looks like? So here you can see a full populated military product in terms of having, let me take you inside into this electronics. So as you can see here, this is a complete military enclosure, so which will be used by army army people. So they will be, the product of this product is for detecting the what is that called, unwanted drones in the airspace and all. So inside this, if you see, you have the complexities related to the power supplies, RF, and you have, this is an FPGA board. So in our products, most of the products we are using zinc based FPGA. So in zinc, the Xilinx zinc FPGA, you have both what you call configurable system on chip approach. That is, you have the ARM9 inside, and you also have the VHDL code that you write and build the high-speed signal processing parts and high-speed logics. So this is an FPGA board. So the complexity inside building a military electronics is all dealt by our integration team. So this is, you can see, this is one plate in which more electronics is present. So in an integrated system, this will be taken and this will go into one more layer. So like that, in a practical system, there is a 3 to 4 layers into which they build the systems. Then we use these instruments to check the performance of the systems. Depending upon the performance of system is up to 6 gigahertz or 12 gigahertz or 20 gigahertz. The instruments will be used to continuously monitor. So even now they have kept this system to monitor some of the characteristics of this circuit before they go to the integration. The further I will to show some of the steps. This is another one system which is integrated system which is getting tested. Further, one of the important step in the military system qualification is to ensure that the system must qualify the environmental conditions like high humidity and all. So special coating will happen. It is one of the step in which, as you can see, the PCB at a level, once it is assembled and before it is going to integration, so they do this coating, conformal coating, by which it becomes resistance against the humidity variations and atmospheric variations. So once this is done, whatever the previous step that we have shown is related to the integration which is after to this. So at this premises, we do the circuit design, we do RF circuit design, we do integration of the system with the different levels of testing, and bring to a stage where it is ready for going to the field trials. Now, I will take you to our rooftop where we carry out the antenna level tests by radiating from one antenna, receiving from another antenna. Of course, within the standard norms that the government has approved, because government gives a level to which in ISM bands you can emit a power. Within that power you can do wireless research indoor and within your premises. So I'll take you there and show you what we do in the radiation mode tests. Before I take you to the rooftop, I thought I'll show you the antenna arrays that we build. So these are the printed antennas designed and developed in our company. So these are the antennas capable of wideband reception. These antenna arrays, when they are in the high number, like 40 antennas and all, so they need to be assembled in a radome and in a structure like this. So let me show you. We also deal with the RF observing material. So the RF observers are very crucial, because in an antenna system, when you are doing a precise algorithms with amplitude, with the phase, with the time delay, it is important that you control the multipath at least within your system. You can't control the multipath outside, and the multipath which is coming outside at algorithm level we deal. So these are the set of antenna arrays which are getting ready for assembly. So these are for the lower frequency band, and these are the broadband for the higher frequency band. So these antenna arrays we assemble in our antenna system. I'll take you now to the top floor to show you that and how do we test radiation mode. Yeah, see, antenna testing usually happens in two styles. One method is called open test range. Then second method is in anechoic chambers. So anechoic chambers are good for actually the precise, but for doing initial level works, people can rely on the open test range. So here we have few setups in which we do test cases. So we have a setup here which is capable of generating a narrow beam signal in wide frequency ranges, right from 100 megahertz to covering up to C band, up to 12 gigahertz, by which we position whatever the system, whatever the antenna array that we want to characterize on the servo systems here, and we calibrate the systems. Then the calibrated data we use in the software for giving the precise detections, direction of arrivals, and location of the location of the signals. I'll also show you one more setup. This is another setup where we are using an X-band horn, and the X-band horn is using as a transmitted antenna, and this is the two-axis servo system. So you have both the azimuth control and you have the elevation control with the two-axis servo system, and you can see here we have a patch array which is getting characterized. So before we go to anechoic chamber and give the final delivery, during the development whatever we need, we actually rely on this open test range, emit a very narrow beam signal, and with that we characterize the performance of the system. So further I'll take you to the software development and what activities we do in the software development catering the military project purposes, both on the FPGA side and on the processor side.